Okay, so let's look at a problem where we see a nuclear equation where there's coefficients in front. So if we look at this first example, and we'll see that there is a missing product, there's something I don't know, and I need to figure out what's the top number, what's the bottom number, and eventually what's the identity of this unknown particle. So I'm going to do the same thing as we did before, where we've got to make sure the top numbers and the bottom numbers on each side are equivalent. So right now on the left-hand side, I have 241 plus 4. So that gives me a total of 245 on the left-hand side as my top number, and I have 95 and a 2, so that gives me a total of 97 on the left-hand side. On the right-hand side, I see that I have a 2 in front, and what that means is that I have 2 neutrons. So when I'm adding up or trying to find my X, my unknown substance, I have to account for the fact that there are 2 neutrons on the right. So what I'm basically doing is I'm multiplying both of these numbers, the top and bottom number, by 2. So on the top, on the right-hand side so far, I have 2 times 1, which is just 2. And on the bottom, I have 2 times 0, which is still 0. So to find the identity of the unknown, I can subtract 245 minus 2, and I'll get a top number of 243. And I can do 97 minus 0, and I get a bottom number of 97. And that gives me the element BK, which goes with atomic number 97. So let's try the next one, example number 2. So same thing where I need to make sure that the top numbers and the bottom numbers on each side are equivalent. And let's start adding up what we've got on the left-hand side. So I have 214, and then I see that I have 2 alpha particles. So I multiply 2 times 4, and I get 8. And I also see that I have 2 beta particles, or 2 electrons, however you want to view that. And again, there's a coefficient in front. So I've got to multiply 2 times 0, which is still just 0. So on the top number on the left-hand side, I've got 214 plus 2 times 4, which is 8. So that gives me, if I write it out, 214 plus 8. Or if I want to say that gives me 222 so far on the left-hand side. As my bottom numbers, I have 84 in PO, and I notice again, I have to multiply these 2 numbers, so I get 2 times 2, I have plus another 4, and I've got to multiply the 2 times the negative 1, so that gives me minus 2, and 84 plus 4 minus 2 ends up giving me 82. So I can write this as my product, 222 over 82, and that gives me the element PB. So in summary, whenever I have a coefficient in front, a factor in front, we have to multiply both the top and bottom numbers by that coefficient when we're trying to find an unknown. Nuclear scientists won't actually do that out in a symbol because we don't want to change the actual mass or the actual charge of a beta particle or of an alpha particle. We just want to show that there is more than one present in this reaction.